Science,
engineering,
medicine, chemistry,
physics,
biology, humanities, cardiology,
computing, public health, global
aeronautics, science communication.
Hello everyone, I'm Gareth Mitchell, and today a very special guest on the podcast, none other than the head of science at NASA. She just happens to be an Imperial alumnus and was speaking to us a few days after that heroic asteroid return mission. And in the interview you may just get the impression that she loves what she does.
You know, it's kind of extreme science in extreme environments with extreme teamwork and leadership. I don't think I could not be passionate and excited about what we do.
See, that's where a degree from this place can get you. And also this month we'll have another pick of the Imperial pods. We're showcasing an all-new podcast that's discussing vaccines for TB.
The Imperial College Podcast.
All right, everybody. Well, I hope you're all well, and let's jump straight in. And as we always do, let's start with a bit of a news update. We have Michael Mills from the Business School. And Michael, I'm going to unpack the whole theory of economics and demographics in one very simple sentence that you can discuss, right? Which is that the baby boomers have all the wealth, the young people have all the debt. Maybe the Business School are now saying there's a bit more nuance to that. So tell me about this new outcome, this new finding that we're discussing.
Yes, well, if you live in the UK, I'm sure you'll be very familiar with that argument. But some new research from James Sefton, Professor of Economics at the Business School, in collaboration with some colleagues from the US and Slovenia, has found that, as you say, maybe there's a little bit more to it than that. And in their recent survey, they've challenged the common narrative that older generations, baby boomers, have got rich at the expense of the younger ones, especially the millennials in terms of wealth and income. What they actually argue is that the distribution of labour income has remained relatively stable across generations. So that means someone in their 30s might earn roughly the same amount as their grandparents did from their work. But a key difference is that younger generations haven't seen the wage rises that older generations might have expected from being more highly educated. People in their 30s these days generally, on average, have a higher level of education. But once upon a time, that would have meant more money. And sadly, it doesn't seem to have such a difference anymore. Another thing they looked at, which always comes up in these debates, and I'm sure is a very hot topic, is that of house prices, asset values. House prices in the last 20 years in the UK, and especially in certain areas, have skyrocketed. And there's a perception that older people have benefited from that, while younger generations have been locked out because they can't afford it, and also their rents are going up because the cost of the mortgage of the person who does own the property. But what's interesting from James's research is that although older generations may have benefited from an increased asset value, that's not translated into higher consumption. Rather than selling their houses and spending all that money on cruises or whatever we think it is they do with it, they're actually more likely to pass it down in bequests to their children. Now, there are some caveats here, of course. One thing to bear in mind, as James points out, is that if that wealth is being passed on privately, that can lead to inequality within generations. If you're lucky enough to have some parents who've got a nice big house to leave you, that obviously gives you an economic advantage that your friend whose parents don't have such a house doesn't have. And perhaps the biggest single caveat that James and his colleagues have flagged up is that we're talking about the private sector here. And the public sector is a very different matter. Public sector net worth, so that's public assets, capital assets, debts and pension liabilities, have dropped off a cliff in the UK since the 1980s, coming close to something like minus 150% of GDP. That's due to a range of factors, but they include things like increases in public expenditure following the financial crisis in the noughties, and more recently the COVID-19 pandemic. But also, as we have an ageing population, there's also increased pension expenditure due to people living longer. People in their 80s today may have been retired since the turn of the millennium, which simply wasn't the case that people stayed retired for that long, brutally, in the past. And commensurate with that, steeply rising health expenditure. And that does create a generational imbalance. And James argues that that's going to require both a political solution and intergenerational cooperation. To use his words, older generations have proven themselves to be good parents, but they might need to become better citizens as well.
What a nuanced, fascinating picture. Maybe some younger people would also, or many younger people would say, well, my grandparents retired with a lovely platinum-plated final salary pension that I'm not going to look forward to as a younger person. But the other thing that they will say is, but we have an ageing population, and it's us young people who are paying for all that to look after all these older people. What about that? Does the report go there, Michael?
Well, no, it's a very good question, and it's one that we really should all be thinking about as a society. The research did look into it, and it has found that the old age dependency ratio, so that's how many people in your population are aged 65 or older compared to how many are aged between 20 to 65, is set to rise to over 50% by 2060. And at the same time, the youth dependency ratio, so that's basically the opposite end, the children and young people that we as a society need to support, people, how many people there are aged 20 or younger compared to how many people there are aged 20 to 65, is projected to be roughly flat. So we're looking to a future where proportionately a lot more of us are going to be older, and we're not going to have that many more young people to pay for them.
All right, yeah. And you don't need to be a champion economist or business school professor to work out that is a bit of a conundrum in our public finances over the decades ahead that we probably won't solve in this short news section. But for now, Michael, wow, thank you. That was absolutely fascinating. That's Michael Mills of the Business School. Well, now, hardly could a keynote address be more timely. Within days of NASA's OSIRIS asteroid sample return mission safely touching down in the Utah desert, who should be a big-name lecturer addressing staff and students here at Imperial? Well, it was only NASA's head of science, Dr. Nicky Fox. Nicky, as she likes to be known, is a physics alumnus from here and was giving a lecture presented by Friends of Imperial College. Now, if you're a stickler for titles, then Nicky's full affiliation is Associate Administrator for the NASA Science Mission Directorate. Quite a thing to have on your LinkedIn profile. Soon after her talk, our very own Hayley Dunning caught up with Nicky. So first on the agenda, that audacious mission to return the space rocks.
What are some of the most exciting projects you're currently working on? I mean, I know the asteroid return mission was outstanding.
So yes, I am extremely proud of the OSIRIS-REx mission, and even more so, I'm extremely proud of the team that did that mission. It was not a simple mission. Things didn't go as planned. When they first got to the asteroid, it didn't look like a smooth surface. They thought it was going to look like a sandy beach, and it looked like very rough terrain with a lot of boulders on that asteroid surface. So they had to kind of do a survey of the asteroid to find somewhere that they could actually land. Then they did that touch and go, and the samples came back. And yes, they've landed in Utah, and they're now at Johnson Space Center. The capsule is open, and the samples are now in the glove box where they're going to start sorting them. So I'm really proud of OSIRIS-REx. And then coming up in October, we will have the launch of Psyche. And Psyche is also going to an asteroid. It is an unusual asteroid because it is made mostly of metal. So Bennu was very different for OSIRIS-REx. It was a very old asteroid, and we think that it probably had some of the signs of what the early solar system was like when it was still forming. It's 4.6 billion years old, that asteroid. But Psyche is a very different one, and so it's very, very metallic. It's like a heavy metal asteroid. It's a heavy metal mission. That's going to tell us about how cores of planets formed, we think. So that's exciting. Just this week, it was the 1-year anniversary of when DART went and hit the asteroid and changed the trajectory. And then later in the fall, we have Lucy, another asteroid mission, making a flyby of Dinkinesh, going around. They're going to have their first near asteroid flyby later this fall. So it's really exciting to see, what we can do with coordinated measurements by looking at different types of things and pulling them together. Of course, I'm always proud of Parker Solar Probe. Parker Solar Probe was my mission, coolest, hottest mission under the sun. I even have Parker Solar Probe necklace on. So there you go. So it's always close to my heart. That one is doing amazing things. We're actually at closest approach right now, closest distance to the sun, fastest object, new records being broken right now. And then in Earth science, we have just all these really great missions looking at air pollution, looking at hurricanes, looking at climate change, looking at how our surface water on Earth is changing. And of course, I would be remiss if I didn't mention the James Webb Telescope and all the incredible images that look more like works of art And I'm going to also give a shout out for all the work we do on the International Space Station. We're flying tissue chips that are living cells inside tiny mechanisms that can mimic human organs and human body functions. We're flying them up in space and doing medical research on those, and also looking at how we would prepare kind of a personalized medical kit for an astronaut that was going to go on a long journey in space. So that was kind of a quick tour of some of the highlights in each of my divisions.
That's amazing, because it really goes right from that small, very, very pertinent to us, just around the Earth, to all the way to the sun. And I know, obviously, Imperial is involved in a few NASA missions as well. We've got the IMAP mission coming up as well, and that's looking right to the edge of the solar system too.
Yes, we're excited. We have a partnership. Actually, Parker Solar Probe has a sister mission called Solar Orbiter. That was a joint ESA-NASA mission. Imperial built the magnetometer for that mission. IMAP, as you say, looking at the very edge of our solar system. So where the sun kind of peters out, where the sun's energy stops and there's no more solar wind, and where interstellar space starts, there's a boundary. And that's kind of our protective boundary that keeps out all the vagaries of interstellar space. IMAP will be studying that. Imperial building the magnetometer for that. And then one of my favorite missions is called Helioswarm. It's a sort of extreme technology. It's really clever technology to do amazing science. It's got a host, or a sort of hub spacecraft, which is a bigger spacecraft, and then 8 little CubeSats that are going to sort of swarm around that hub. And if you think about it, you've then got kind of 9 points. You can form multiple, I think it's like 156 tetrahedron that you can form. So you can look at all different scale sizes of turbulence out in the solar wind. And Imperial College building all 9 magnetometers for that. So JUICE, which we have NASA contributions on JUICE, and then we will have a partner mission to that called Europa Clipper that will launch next year. And so, really excited to look at all the science we can do together with those 2 missions out around icy moons of Jupiter.
Now, you're obviously extremely passionate about what you do, and I've read somewhere that you said you have the best job in the world. So what gives you that passion?
So I have the best job on and off the planet. It's kind of extreme science in extreme environments with extreme teamwork and leadership. I don't think I could not be passionate and excited about what we do.
It sounds like you really enjoy about NASA is that it seems to be for everyone. And we hear a lot, about women in STEM subjects and women in physics in particular. And I know when you did physics at Imperial, you were perhaps in the minority. So how does it feel to be a woman in this position, and what do you think we could do to encourage more?
So there are a lot of women in leadership roles at NASA, and I do think we're seeing a change in more women coming into these roles. I know that physics in particular is still a challenge, and I really think we need to be looking at our sort of early years in senior school. Often by the time people turn even 13, 14, they've already decided physics is not for them. And I think we really need to look at what we're doing in our primary schools to just show how fun science is, and science isn't hard and it isn't scary. Anyone can do science, so you don't have to have a PhD to do science. If you just are curious and you like asking questions, you're actually a scientist. If I ask you what's the time, you are going to hear the question, you're going to look at your watch, you're going to take the apparatus you have, you're going to take data, you're going to make a conclusion, and you're going to present your conclusion to me by telling me what time it is. That's a scientific experiment. That's scientific method. Everybody uses it every day. And I think we need to start talking about science more in that term. It's not scary, and you don't have to be some super geeky nerd, even though I am, to be a scientist.
Nicky Fox speaking there to Hayley Dunning. Well, let's go now for our regular foray into the Imperial College podcast scene, and a very busy scene it is too. Our departments, schools, centres and students are bringing out new titles almost every week, it seems. That's why we've created the Imperial College podcast directory to help you find the perfect listen for you. Our pick this month is tuberculosis related.
Hi, I'm Tom Rawson. I'm a researcher in the School of Medicine's Jameel Institute and also the producer of the new podcast, JameelCast. So the Jameel Institute is a group of researchers who study global disease and global health, but specifically we look at a lot of the areas where that overlaps with other fields. By training, we're a group of epidemiologists, economists, engineers, physicists, ecologists, and putting together all these different perspectives and skill sets, we help solve some of the trickiest public health problems. And so with so many different backgrounds, that means you get a lot of very different stories to tell as well. So each episode of JameelCast is spotlighting one particular researcher in our group and their work, giving an interesting insight into a problem that you might not know about, and how that researcher's work is contributing to a solution. It's available now wherever you get your podcasts, and to give you a flavour of what to expect, here's an extract for you from our episode with Professor Nim Pathy, all about his work studying the world's burden of tuberculosis. Nim works a lot in the field in countries with a lot of TB, like India, and in this clip, Nim tells us a bit about some of the unexpected ways that trying to fight this disease can face difficulties.
When we do prevalence surveys and we go out into the community to find TB, there are people who have TB who were symptomatic, they were sick, they were suffering from the disease, but they had never sought care. They'd never gone to see a doctor. The reasons are many, but I think one of the most interesting is that, again, TB is a disease of poverty. There may be, for example, a daily wage laborer who may be symptomatic. And for them, going to see a doctor means taking time off work and means lost income. And so these individuals are going to tolerate their symptoms until the last possible minute and then only go to see a doctor. There are also other possible reasons. It's very interesting in some urban settings, for example, where air quality is very poor. Everybody is coughing. Cough is one of the classic symptoms of TB, but it can be so non-specific in settings where you have many other causes for cough. I think the reasons can be quite complex and multiple. But the other interesting thing is, so in many South Asian countries, there is a huge private healthcare sector. They don't necessarily cooperate with the public health authorities. They don't report the TB cases that they handle to the government. And so this can really mean complications in terms of trying to monitor how many people are receiving TB treatment. Most people would rather pay to go and see a private doctor than access free, high-quality TB care from the government. Again, thinking about the daily wage laborer. This daily wage laborer may prefer to pay to visit a private doctor out of hours than to visit a government clinic that they might otherwise have to take time off from their work. The cost to them is actually less going to a private doctor. So there's a lot of energy coming through the program, and there's a challenge now in inviting the patients to take up these tools for which they're eligible, take up these medicines from which they would benefit. But I'm very optimistic, given the amount of energy that's really coming through the program right now, that the patients can be brought along as well. It's only through understanding these unexpected factors that we can really understand how better to align these TB services with the patients in need.
With such intense pressure to meet these ambitious goals you've heard about, other researchers across the technological and pharmaceutical sectors are presenting brand new advances every year, new tools in the tool belt for Nim and other researchers to consider and factor into their policy support work.
More recently, one of the interventions that's gaining momentum in India is the use of what we call digital chest X-ray. Now, chest X-ray is one of the ways in which you screen people for TB. So you find people that you should be testing. You should be taking sputum from them and testing them to see whether they have TB. Getting sputum from somebody to test is actually surprisingly hard. They're not just spitting into a cup. You're really asking them to expectorate. Often programs need multiple sputum tests, and these are then sent off to the laboratory. There's some expense involved in the testing of that. Obviously, you can't go around and test everybody, but a chest X-ray helps to determine which people you should test. You look for shadows on that chest X-ray. And recently, we're having the development of these new tools, digital chest X-ray, that are then read by artificial intelligence. And those new tools can then help to identify very rapidly the patients who should be tested, that you should be taking sputum from. And what this means is that we now have the possibility of much wider screening in the population.
You may, however, have noticed so far a distinct lack of one of the ultimate medical interventions: vaccination.
We have even more need nowadays than ever before for a new preventive vaccine. So far, the only licensed vaccine has been the BCG vaccine, but unfortunately that only protects very young people from the severe form of disease. So TB is not yet a vaccine-preventable disease, and we urgently need a vaccine that allows us to call TB a vaccine-preventable disease. So developing a TB vaccine is hard, scientifically hard, and One of the reasons is that we don't fully understand the immunology. For diseases such as flu, for example, we have a reasonable idea of what we call correlates of protection, which is you should raise these antibodies and you can do these tests and that'll tell you that somebody has this level of immunity. And unfortunately, we just don't have that for TB. We don't have that good an understanding of what makes good immunity against TB and therefore what a vaccine should raise.
That podcast again is JameelCast. I hope you'll enjoy the rest of the series.
We certainly will. Tom Rawson there. And that's it for this podcast. So don't forget to dip into our Imperial College podcast directory to choose whatever listen you're interested in. So many different subjects and topics there for you to choose from. And of course, day by day, week by week, you can catch up with what's going on around Imperial, the news and events here via our news website. So that's imperial.ac.uk/news. Well, I'm Gareth Mitchell saying a very fond farewell from me and all of us on the podcast team. Have a lovely month, won't you? Bye-bye.